A new subject, capacity planning. Most importantly though, we're going to be using one of the more powerful tools in Excel, which is the solver function. Now just to see what the solver function is, if we go up to the data tab on the ribbon and across to here we have our solver function. Now as it says there, solver is a what-if analysis tool that finds the optimal value of a target cell by changing values in cells used to calculate the target cell. What this means is we can set up a problem and we can leave some of the cells blank. Now the ones that we leave blank are going to be used in the calculations. And what solver will do is it will go through and it will try a variety of different values. It will put them in those cells and it will keep trying this and it will try and get the target cell to the right sort of value. And in this case we want the target cell to be, it will be this value down here, which will be the total costs for the problem, and we're going to try and minimize that. Now just looking down the problem, these cells here which are highlighted in sort of an orange colour, those are the cells which the solver function are going to change the values for. And when it changes those values, it's going to attempt to minimize the total costs. Now if we followed the instructions, we've taken the capacity planning spreadsheet and we've saved it onto our J drive. Now the problem statement reads that there's a changing level of demand for jandals. Now at the beginning of month 1 they have 500 pairs of jandals on hand and they have 100 workers. Each worker is paid $2,400 per month and they can work up to 160 hours per month. It takes 4 hours of labour and $15 of raw materials for the workers to produce each pair of jandals. At the beginning of each month, workers can be hired or fired. Hiring each worker costs $2,000 and firing each worker costs $4,000. At the end of each month, a holding cost of $3 per pair of jandals will be applied. What does this mean? Well, what we're going to be doing is we're going to be varying the level of capacity in this problem to try and meet demand as best we can. And the way in which we're going to change capacity is by hiring and firing the workers in the worker plan. So, beginning, the hiring and the firing plan. Now, the workers from the previous month in this cell, in B15, is calculated simply by using the initial number of workers. So the initial number of workers was 100. And in the second month, the initial number of workers will be given by the number of workers available from the previous month, like that. Now, the workers available after the hiring and firing is the initial number of workers each month plus the workers hired minus the workers fired. And we can just drag that across like that. Now, these values in these shaded cells in orange, as I mentioned before, are going to be adjusted by the solver function, so we don't need to put anything in there. But what this has done is it's giving us a method of changing our capacity, and we'll just see if this works. If we hire 5 workers in the first month, we can see the workers available after hire-fire changes to 105, and the next month we have 105 workers at the start. If we fired 5 workers in that month, it would drop back down to 100 again, and next month it starts with 100. So those calculations seem to be working well. Turning the page, calculating the hours available, simply the workers available after hire or fire multiplied by the regular hours per worker per month. And if we hit F4 now, we look at the equation, we hit F4 and you'll see it's now got an absolute reference to the regular hours per worker per month. And we can drag that across there, like that. Brilliant. Now the production plan. The production plan is going to tell us how many jandals need to be produced in order to meet demand. First of all, we want to calculate the jandals produced. Well, obviously we do. That's part of the production plan. But in this case, you'll notice that it's shaded again, and this means that Solver will be determining the number of jandals to produce. So we're going to just leave those blank for now. Now our production capacity is given by the number of jandals that can be made every day by the workers. So the production capacity will involve the hours available and the labour hours per period jandals. So if we take the labour hours available for the first month and divide it by the labour hours per period jandals, we hit F4, make an absolute reference to the labour hours per period jandals, we hit enter. Now if we change that and just replicate that just across the cells like that, we have our production capacity set up. Now you'll see here we've got a less than or equal to sign. Now we don't have to have those in place, but it's just useful to remind us what we're doing here. We want the number of jandals produced to be less than or equal to our production capacity. It would not make any sense in this problem to have a solution that was like this. 5,000 jandals. How can we produce 5,000 jandals if we only have production capacity for 4,000 pairs of jandals? We can't. So what this constraint is reminding us is that the value that goes into these cells here, the number of jandals produced, must be less than or equal to our production capacity for the relevant month. The next thing we're going to do is calculate the inventory after production. For the first month, this value is given by the production of jandals for the first month, added to the inventory that was already held. So first of all, we know that we are holding 500 pairs of jandals at our inventory, and we're going to add to this the number of jandals produced. That'll give us the total number of jandals that are going to be available for sale after production. Now that's only for the first month. The subsequent months, month 2 onwards, it'll be different. So in month 2 the value will be given by the production for this month, plus the ending inventory for the previous month, like so. Now down in the demand category, you can see that I've neglected to enter the demand from the problem. So if we go back to page 3, we can see the demand was 3,000 for the first month, 5,000 for the second month, 2,000 for the third month, and 1,000 for the final month. Now, you'll see that we have a greater than or equals to sign there. The reason for that is that we want the inventory after production, which is the total number of pairs of jandals that we have available, to be greater than the demand. If it's greater than the demand, we can meet all of the demand and earn more money. If the inventory after production was less than the demand, we would not be able to meet all of the demand, and we have missed the opportunity to earn more revenue. Now in the ending inventory, this value is always going to be equal to 0 or a positive number. We don't want any negative inventory or back orders. So the ending inventory is going to be left over after the demand has been met. So the ending inventory will be equal to the inventory after production minus the demand. Now obviously there it's giving us a wee bit of an unusual answer, but we haven't solved the problem yet, so that's not unexpected. And we'll just pull it over like that. Now, the summary of costs. First thing to do is the hiring costs. The hiring costs will be equal to the workers available after hiring and firing, multiplied, the hiring costs will be equal to the workers hired multiplied by the hiring cost per worker. And we're going to hit F4, so it's an absolute reference to that value. Now obviously here it's 0 because we don't have anything in those number of workers hired cell. Firing costs will be similar, will be the number of workers fired multiplied by the firing cost per worker. And again we're going to hit F4, and by doing that we have an absolute reference to that cell. We hit enter and we can drag this across now. Wages will be equal to the actual workers available that we're going to be paying for the month multiplied by the regular wages per worker per month. And again we hit F4, so we have an absolute reference. The raw material costs will be the raw material costs associated with the production. So we want to find the number of jandals produced, multiply that by the raw material costs per pair of jandals. And again we want to hit F4, so it's an absolute reference. And drag that across. And the holding costs are the amount of money we pay for holding inventory, and this will be equal to the ending inventory for each month multiplied by the holding costs per pair per month. And again we hit F4 for an absolute reference, and we drag that across. I just want the sum of those rows and now we want the sum of those columns. And the total costs will be equal to the total costs incurred over that period. Now, that's the first step. We now have our spreadsheet set up, and if we want to enter some figures, we could enter some figures and work out a solution. So if we entered 4,000 jandals there, 4,000 jandals here, now that meets our production capacity each time, and that's just because we have, it takes 4 labour hours per pair of jandals, so our production capacity was dependent on the hours available. So each time we've used all of our capacity, and you can see we've got ending inventory, and it builds up quite a bit near the end. Now this is going to give us a value of $1,230,000, and I'm sure we can do better than that. And the way we're going to do better than that is by varying those numbers in there. So we come up to this tab up here for data, and we come across here to the solver function. Click on the solver. We're going to set the target cell to F38. That's the total cost figure. Hit enter. We want to minimize that. We want to reduce the cost as much as possible. We're going to change the cells. We're going to make it the workers hired and fired, comma for the next set, and we're going to make it the jandals produced will be the other cells. The Excel is going to change for us. and we hit enter. Now the constraints. The workers hired must be an integer, and the workers fired must also be an integer. So the constraint we're going to add here is we're going to select the workers hired row, and we're going to make that an integer. Okay. Another one we're going to add is the workers fired row, and again we're going to make that an integer. Now the values must be non-negative, so we're going to click on the options and click on the assume non-negative. Okay, so the options button is just there on the right hand side of the solver parameters box. But we're not done with our constraints. The jandals produced must be less than or equal to the production capacity. So if we click on these cells here, the jandals produced must be less than or equal to the production capacity. Fantastic, so we add that constraint. Jandals produced must be greater than or equal to 0. Fairly obviously we can't produce a negative level of jandals. Now this is also taken care of, must be greater than or equal to 0. That was also taken care of using the solver option box and the clicking assume non-negative values. Now the inventory after production must be greater than or equal to demand so that we can meet all demand all of the time. We click on OK. So now we have a series of constraints. We have a target cell, we want to minimize it, and we've told Excel which cells to change. Now we just hit solver. Now we let solver do its thing, and it's given us a value here of 1,052,000. So you can see that was quite a big improvement. And if you just look up and see what solver's done, it's fired 3 workers in the first month, 6 workers in the second month, 41 workers in the third month, and in the final month no workers have been hired or fired. We check our constraints. Each time the jandals produced was less than the production capacity. Each time the inventory after production was greater than or equal to demand. We had some inventory there, and that helped us to meet the demand the next month. So that all looks good. You see that we've got no workers hired at all on this problem, and there are no hiring costs at all. So, well done, you have just completed your first capacity planning problem. Congratulations.